Aloha and welcome to this module on using controllers in the Play framework. And I'm assuming that you've already gone through the module on entities, or the module on models, I should say, in the Play framework, because we're going to build upon that understanding of models to develop controllers. So just to briefly review, remember we got this model view controller paradigm in Play. We've already talked about the models kind of in isolation, and that was really great. So we didn't have to worry about what controllers or views did. We could purely focus on how to do models, how to persist them. Now we're going to expand our focus, and we're going to take into account the controller, but we're still going to almost completely ignore the view. There's one little tiny place where we're going to use viewish stuff, but not really. And this is kind of a neat thing about this architectural paradigm is we can slowly build up our understanding of how to do it and not have to worry about all three of these things at once. This is, when an architecture is designed well, you get this kind of nice feature. Now I'm gonna say, although, even though I'm introducing the Play framework in terms of looking only at the model, then only looking at the controller, then only looking at the view, I do not recommend that this is the way you actually do web application development. I'll come back to that a little bit later. So in the controller, we're going to think about the following basic pieces. We've got our browser. Our browser is going to issue an HTTP request, and it's going to be handled by this Play component called the router. And we configure the router via a routes file. Based upon the data in the routes file, whenever the browser sends a request to our system, the router is going to get that request, and it's going to figure out which of the action methods that you are implementing is going to be invoked. And the mapping from HTTP requests to action methods is done in this routes file. The action method is where you're going to actually process the request, decide what you want to do in your app, and then generate a response back to the client. And we're going to have some really simplistic business logic or processing in our action methods. But the one part I'm going to highlight is a very important component of any kind of business logic, which is validation. And there's some stuff that's standard patterns that you use to do validation, and we're gonna touch on some of them in this module right here. Okay, so first let's focus on this component called the router and figure out how that works. Basically, you don't really need to look at the router code at all. All of the routing stuff is combined within a single file in the conf directory called routes, and this looks like your basic text file. And if you're familiar with Ruby on Rails or other frameworks, you've probably seen this before, and it's pretty easy. Basically, things with a hashtag are comments, and then a line will have an HTTP method, and then some kind of route string, and then it will have the fully qualified path name to the particular method that will be invoked when this pattern is satisfied. I say pattern because it turns out that you can have variables in your pattern. So this one is basically saying get products with some kind of string, well, in this case actually some kind of long value that indicates an ID. Okay, and then if there's a long that follows this product string, then it will match this particular line and will invoke the details method with an actual long value. Now remember, when you're sending stuff around the net, you're sending all strings. Okay, so one of the nice things that this routing system will do for you is that if you declare over here that this ID variable is a long value, then if you send something that's not a long value in as your value, it's not going to match this particular method. In fact, I don't know what it'll match. It'll probably match it's a good question what this will match. I don't know. But it's not going to match this particular one. So you get a certain amount of type safety in this. Okay, and then there's this bottom line. You can read about it in the documentation. Basically, this is a way of serving up JavaScript and other client-side files. Okay, so when we're designing our routes for our application, we're going to have to specify an HTTP operation. That's usually get, put, delete, post. There's also the head operation if you want to do that, and then the particular method that you want to have invoked, based upon the pattern that you supply. And these patterns can support variables, query parameters. You can provide default values for parameters if they're missing, and other kinds of cool stuff. Now the routes package, even though it just looks like an ASCII text file, that's what you're going to think in your brain, it's actually a Scala class definition. This is like part of the wonder of using Scala as an implementation mechanism for this. And what I think gives play some of its definite coolness is the idea that really this routes file is going to be compiled. It's going to produce a class and an instance, and there will be type safety, and if there is not an action method corresponding to that's compiled and is available, when you try to compile this routes package, you're going to get a compile time error. So you're going to get consistency checking with the routes file, which is something that doesn't normally happen at compile time in Ruby on Rails or other kinds of systems with this. So this is kind of a cool feature. Another cool thing that is provided by the router is reverse routing. Okay, so normally you kind of think going left to right. So you're going to have an HTTP request like get/, and then you're going to figure out what is the method that you want to invoke when you receive that HTTP request. Okay, but you could also go the other way. So you could take an actual action, and then, because it's kind of a one-to-one correspondence, then you can go back and decide what the HTTP request you would need. Okay, this is called reverse routing, and it turns out that it simplifies lots of things. One of the things that really simplifies is redirection. So in your code, if you in an action method you realize that based upon the current state, you actually want to invoke another action method, you can basically take the action method and use that as the call, and then the system will recreate the HTTP requests and then send it through the router again. Also, when you do testing, it makes doing testing very convenient, and we'll see that in the walkthrough. Okay, so that's the basic syntax of the routes file. Now there's one more little thing we have to worry about, which is, well, how do we decide what are good patterns and what's a good structure for the set of HTTP operations that our system should support? This turns out to be an incredibly knotty problem, and is the subject of a lot of debate within the community. I have some readings that I would like you to look at. I could spend multiple lectures just talking about this single issue, and so I'm not going to do that. I'm going to kind of punt and just have a couple slides on this issue. But I want to bring up the idea of REST, which stands for Representational State Transfer. It was coined in a PhD dissertation by Roy Fielding in, I don't know, 1995 or 6 or 2000, early 2000, something like that. And this proposes a set of design principles for distributed architectures, including the World Wide Web. There are people who believe very strongly in the principles of REST as set forth in Fielding's dissertation. These folks are often referred to as Restafarians. I like that one. And then there's other people who say, REST is kind of a cool idea. We like it, but we're not going to take it so literally. And these people often refer to themselves as REST pragmatists. The Restafarians don't like these pragmatists even using the word REST with respect to what they are doing, because they don't think that they're, if you're not doing REST the whole way, you shouldn't even call it REST. So in this class, we're going to come down on the pragmatist side, which will, which is an irritation to the purists, but that's just what we're going to do. And I have some readings on Pragmatic REST. You can read through it. But basically, the notion is you're going to have a resource. The resource is generally specified in terms of names rather than verbs. And then the there's actually another one, head, but the 4 basic HTTP operations, post, get, put, delete, correspond to create, read, update, and delete, the kind of the CRUD stuff from the database. And from that, you get a certain kind of API which makes it fairly intuitive and obvious how you can manipulate the objects in your application. It works in the simple case in a fairly straightforward way, but there's a lot of devils in the details that start to come out when you're doing user interfaces, and so we're going to kind of slide a little bit on the pure REST stuff to make your life easy, and because I honestly don't feel that the Restafarians have actually made a convincing case that we should all be extremely strict with respect to REST principles. But it is an interesting notion. I don't know what the ultimate answer is. I think nobody in the community really knows what it is. It will be sometime in the future that we figure this out. Okay, so assuming that you've developed your routes file and you have this mapping between your HTTP requests developed in some kind of pseudo REST style, then we're going to have action methods, and mainly I'm going to teach you about the action methods by showing you them in the walkthrough, but I'm just going to give you a brief overview of them right now. They're a static method. They take parameters and return an instance of the results class. The result is the object that basically gets rendered in the browser as the result of whatever this request is. And by default, these are classes that extend controller and then the controller's package. So what they look like, it's basically pretty simple what happens. At the top of this page, you can see kind of my outline of it. It's always going to return a result object. You've got the name of it, which is the action. It can take some params. Then you've got a bunch of business logic, which is processing the params based upon the current state of the system. And then you're going to return a response, which indicates whether it was successful, so for example, OK, whether it was a bad request, whether you got an internal server error, whatever this is. These correspond generally to HTTP response codes, along with some optional content which is displayed in the browser. So here's a simple example. We have this action method called list. It's a static method. It returns a result. It basically goes out to the database, gets all of the product instances in the database currently, and then it's going to return OK and return a string that is this set of products. Okay. Normally we'd have a whole bunch of view stuff, right? That's going to lay it out in a table and maybe have some Ajax and Lord knows what. But in this module, we're going to have our responses be just simple strings, and our view is basically nothing more than passing a string back to the browser, which will be displayed in the browser, so it works. But one of the nice things is that we can really kind of not worry at all about the complexities of building templates and views and all that kind of stuff when we're just trying to understand how controllers work. So there's a lot of different good result objects you can pass back. Here's some of the the most important ones. OK when things are OK, and then a bad request if for some reason the user didn't supply the correct parameters, or the whatever constraints of the request were violated. You can have a created response. Redirect, forbidden if they haven't, for example, logged in, but they still constructed a URL which would require authentication. And play has this object, result object. So these are methods that are going to build and return a result object. This is actually just a singleton instance of the result class called to-do. You can also return that sucker, and that will return the 501 not implemented, actually even display a little page saying we haven't done it yet. This is nice during development, so you can write action methods that just have the single body return to-do, and now your routes file will actually compile. Okay, which is good, right? Remember, we have to have action methods in existence for everything in the routes file. But if you actually try to invoke that action method in your test classes or whatever, you'll get you get 501. Okay, so the key thing that I wanted to provide an overview at this point is the notion that we want to do validation, right? So we want to make sure that when people, like if they're creating an object, they're providing all the correct parameters for it. If they're, whatever kind of operation they're trying to do, we want to make sure that the data that they pass is appropriate, okay? And there's really a couple different places that you want to do validation. In modern web applications, you'd like, when the user is displaying a form, what you'd like to be able to do is have them type in, like let's say there's a field that's supposed to take a phone number. You'd like them to type in their phone number, and then without even going to the server, you'd like the client to sit there and look at that phone number and go, okay, is it 3 digits and then a dash and then 3 digits and then a dash and then 4 digits, or whatever your pattern is. And then if the user hasn't typed that in the appropriate pattern, your form should indicate an error right then and there. Okay, so that's great. We want to do that. That makes it for a much nicer user experience. But that is not sufficient, and it's not sufficient because you can't guarantee that your user is actually invoking your server through this beautiful application that you've built. Because as you know, right, you have your beautiful application. Well, that beautiful application then ultimately is going to make an HTTP, it's going to generate an HTTP request and send that out to your server, which then has to interpret it. Well, there's nothing to prevent a user from generating an HTTP request to your server through some other program where you have not, created all of this beautiful validation stuff. Okay, so even though it's nice from the user experience side to make sure that your forms are doing all this client-side stuff, you still have to validate the HTTP request on the server side to make sure that people aren't doing something different from whatever your user interface did. And of course, this can create security risks and everything else if you don't do any validation within the server. So the typical place that you do validation is within these controller action methods. Since we're not doing views this week, we're not going to worry about number one, the validating the forms on the client side. We're going to talk about validation in the controller, which is a good place because when you do the validation there, it doesn't matter what client the user was using to actually create that request. You're going to take care of it. Okay, so there's the way this generally works is that there's certain kinds of validation that are property of your entities. So if you have an entity that maybe it has some field quantity, and quantity has to be between 1 and 100. Okay, what you can do is you can actually annotate those fields within your entity class definition with annotations that actually specify that validation, and that's very nice because it's very declarative. And then in your action method, we'll go through this kind of unintuitive process of basically checking to make sure that the data that was passed is indeed satisfying the validation conditions that you've specified in your entity. Okay? And the way this is going to work is that we're going to create a form object and pass it the class name or the class instance of your particular entity. And then we can bind the request data to that form object, okay? Which means that form object now actually is kind of like, it's like a hypothetical entity. It's not a real entity. We haven't actually created a new instance of our entity class like product or warehouse or whatever, but it's this form object that really has everything that would be needed to create an entity if we wanted to do so, okay? So this form object is kind of hanging out there in space in your controller object. And then what we're going to do is we're going to call the has errors method on it. And that has errors method on when invoked on this form thing will say, what is the entity that's supposed to be associated with this form? I'm going to go out, I'm going to look at those annotations. I'm going to check to make sure that if we were to create an entity based upon the data in this form, it would satisfy all those constraints. If so, has errors returns false, so we're all good. If, however, we were to create an entity out of the data in this form object, it would violate the constraints. Has errors will be true. Okay, so you got to do that kind of manually, call this has errors thing. But if it passes, then you can call this get method on the form, and then the get method on that form object will actually go ahead and return to you an instance of that entity based upon the data in that form, which we now know satisfies all of the constraints. Now, why, you might ask yourself, why do we have to explicitly call this has errors method? Why don't we just call the get method and have it throw an exception or whatever? Well, the reason is because the constraints that you specify with respect to the fields in an entity definition are not the only constraints that may have to be satisfied. So there may be multiple levels, and you may want to make sure that there's information across fields which has to be consistent with each other, or even across entities. There may be all sorts of ways that you want to do validation before you actually say, okay, I'm going to give the go-ahead to create this entity. So we have this kind of process which at least takes care of the entity level validation prior to the actual creation of an entity instance. And that's kind of nice, because you really don't want entity instances sitting out there in your program that aren't valid, are semantically, bogus. Okay, so here's some of the validation annotations that come in play. You can look in the play.data.validation.constraints package for them. You can test to make sure that if it's like an integer value, what the maximum value of that integer is. If it's a string value, what the maximum length of that string would be. Same for a minimum value, minimum length of a string. You can have basically a regular expression pattern that you can test it. You can basically say, okay, this field has to be non-null. That's the required. This field has an email address, and so it's got to satisfy the email, kind of constraints. And then you can have a validate with, which enables you to specify some code that will be run. And then also within an entity definition, you can actually just define a validate method that can do anything it wants to do, and that will also be invoked as part of this whole overall validation process. And we'll see examples of this in our controller walkthrough package. Okay. Last step, testing. Okay, we'll create a test controller class. We'll call an @test method. It's going to go through each of the controllers that we define. And we want to exercise each route. Typically, you want to make sure for each route that you're actually invoking the right action method, that the validation rules that you specify are being applied. So you might invoke the controller with data that's both valid and data that violates each of the validation constraints to make sure that the entity is not created. And then whatever other kind of business logic, even if it's valid with respect to the kind of the syntax and the entities, you want to make sure that it's computing the correct answer for whatever it is that you're trying to do. Okay, there we go, and on to the walkthrough.